Dear students, detailed civil engineering courses like Manual Building Design, STAT Pro, ETABS, SAP, Revit, AutoCAD, Primavera, P6 are available at Civil Engineering Shravan online application app. So download the application from the Google Play Store now. Each course contains 50 plus high quality video contents and free PDFs and exercises, and online certification will be provided after completing the course. Course will be available at 67 to 70% discount now and valid up to 6 months. Download civil engineering application now from Google Play Store, or direct link is available at the description of this video. Try to utilize this offer. Hello everyone, welcome back to my YouTube channel Civil Engineering by Shravan. In this video, I will explain you complete analysis and designing of duplex house by using ETABS software. So for that, firstly I am selecting my duplex plan. So this is the plan which is related to duplex house. It is consisting of the ground floor like parking and 1 BHK house plan. Again, it will be consisting of the first floor which is of the duplex house, complete duplex house, and second floor is also duplex house. So firstly we will assume the column positions for this duplex house. Just I am taking, this is the first column, this is second one, this is the third column, fourth column, fifth column, sixth column I am assuming here, this is seventh column, this is eighth, this is ninth. In the same process, this is the 10th, 11th, 12th column I am assuming here. The center to center distance between this values, just I am assuming here as 3 meter, this is 4 meter. Again I am taking, this is 3 meter, this is 3 meter, this is just I am assuming here as 5 meter here. The total length of the building is approximately 7 meter according to the consideration with the 3 number of the lines, and y direction will be consisting of 11 meter with 4 number of the lines. So I will do the analysis process and designing process by using ETABS software for this duplex house. The center to center distance between the column is same for each and every floor for this model. So I will open the ETABS software now. Go to click on the ETABS software. Now we will select the file option here. Click on the new model option. Now we will select the use built-in settings. Select display units in metric SI according to Indian. Steel is IS 800, concrete is IS 456. Now we will enter the number of the lines which is exist in horizontal direction, which is consisting of 3 numbers in horizontal direction, X direction, Y direction is 4 numbers here. So here I am entering number of direction values are 3. Again these are the 4. Default spacing I am assuming here as 4 and 4. Now we will change the spacing. Click on this option. Click on edit option. So now we will enter the spacing in a horizontal direction. For the first one it is consisting of 3 meter. Second one is 4 meter. And Y direction we will consider 5 meter here. Again this is 3 meter. In the same process I will consider this is 3 meter. Click on OK option. After this we have to enter the number of the stories. For this duplex house plan, it is consisting of the G ground floor section plus 2 story section, which is of G plus 2. Along with that, I will add the plinth level also for this model, so that it will make the total stories are 4 here. Okay, so that's why just I am selecting here as 4 number of the stories. Each will be consisting of 3 meter, 3 meter. Click on grade only option, click on OK option. Now after this we have to define the material properties like grade of the concrete, grade of the steel for this duplex house plan. So for that just I am selecting define option here. Click on material properties. Initially I will define the material related to Indian concrete M25 grade concrete provision. Click on OK. After this we will define the one more material which is related to the rebar according to IS 500, sorry HOSD 500 grade. Click on OK option. Again we will add this. So after this we will define the dimensions related to the column, beam, etc. So define option, select section properties. Just I am assuming the frame. Initially we will delete all the properties which is exist here for the building model. Click on delete option, click on OK. Now we will add the new property. Select the rectangular property. Just I am giving the property name as column, which is consisting of the material is M25 grade concrete provision. So depth I am assuming here as 460 for the beam, and width as 0.3 here for this particular model, sorry 300 not 3. So click on the reinforcement option, select here as beam. So you can change the modify the property. So sorry, it is not beam, it is column actually. So we will change the properties longitudinal conformamental bar here, and we will change the cover according to the consideration. Just I am taking the cover is 30 mm cover, which is consisting of approximately 3 bars in this direction and 4 bars in this particular vertical direction. So click on OK option. Now we will click on OK. Now I am selecting ISLB, click on delete. Add option. Again I am adding the beam, which is consisting of dimensions as, let us take 300 cross 300 for the beam. Just I am taking here, click on reinforcement option, select the beam option. Just I am selecting HOSD 500 500, 30 is the top as well as 30 is the bottom section. Click on OK, click on OK, click on OK. After this we will define the slab thickness. Go to select option, go to define option, section property related to slab section. Delete this property. We'll modify the property. So according to IS code, just I am taking slab 125, which is of M25 grade with the thickness as 125. Click on OK so that it will add the thickness for the building structural model. So after this we will assign those properties. Select all stories initially. Click on this beam. Just we will change the property to the beam here. Click on assign option so that it will assign the properties. Now we will select the I section, which is related to the columns. We will assign those property, but you can see here it is having the orientation in horizontal direction. We will change that particular orientation to vertical direction. For that we will change the orientation angle. Why? Because the length of the building is higher in this vertical direction for this model. Just I am selecting I section here. Change the degree angle to 90 degree here. Click on select this option. Just we will draw the columns here. In the same process we will draw the slabs. Go to select the slabs option here. Change the property name from deck 1 to slab 125. This we will drag to the model here like this, so that it will draw the slab section for the building modular structure. Now we will delete the slabs at the ground story as well as the plinth level. So we will firstly modify this property. Go to modify option. This is footing level. This is plinth level. This is ground floor. This is first floor. Again this is second floor. Click on OK. Click on OK option. Now we will select. Go to select option. We will delete the slab section at the ground story level. Go to select option. Go to select stories. Just I am selecting foundation level. Click on edit option. Delete property. After this we will delete the properties at the first story level also, which is nothing but your ground story level. Which is nothing but your plinth level. Go to top section here. Again we will select the one story option here for this particular model. Just I am selecting the slab section members here for this model. Click on edit option, click on delete option, so that it will delete the slab section property at the plinth level. Now after this we will define the load cases for this building model. Go to define option, select load patterns. Just I am assuming the building structure was located in zone 2 seismic condition system. No need to apply the seismic loading condition system for this building. So here you can see the building is G+2. It is having 9 meter height only, which is less than 10 meter height. According to IS 875 part 3 code, it is suggesting that we will consider the wind loading condition system if the building height is exceeding 9 meter, which is approximately 10 meter. So we will consider, but here it is not exceeding 10 meter. So it is approximately equal to 9 meter from this plinth level. So that's why no need to apply the seismic loading condition system. Why? Because we are taking a zone 2 seismic condition and wind loading condition system because of the height. We will apply only the gravitational loading condition system. Firstly, I am selecting all the building. Go to assign, joint loads. Initially, I am selecting forces. Click on add to existing load. We will change the force value to 1111 here. Click on apply option so that it will apply the floors for this building structural model with the self-weight condition system. After this we will apply the load which is related to the wall loading condition system, which is the combination of external wall, internal wall, parapet wall loading condition. Basically we need to calculate that particular loading condition system. In the previous videos I was done with calculation, but once again I will do the calculation. So this is the thickness of the external wall. We need to multiply this wall with the height of the wall, and we need to multiply this value with the unit weight of the brickwork, so that it can get the values approximately 13.8. In the same process we will consider the internal wall, which is consisting of 125. We have to multiply this respected value with 20 with the height of 3 meters, so that it can get the values 7.5. Again in the same process we will consider the parapet wall load, which is consisting of 0.125 thickness, which is placed at a distance of 1.42 meter from the slab. Again we will multiply this value with the unit weight of the brickwork so that it can get the value is 3. So 13.8 plus 7.5 plus 3, which is approximately equal to 24.3 kilonewton per meter we need to apply for the beams. Go to select properties frame section related to the beams initially. After this we will apply that. Go to assign option, frame line load, distributed condition, add to existing condition. We will change that value to 24.3 kilonewton per meter. Click on apply so that it will apply the load which is related to the wall loading condition system. After this we will apply the load as per the slab loading condition. For that go to select option, select properties slab section. This time selecting slab 125. Go to assign. This time selecting shell loads uniform. So we will add the load which is related to the thickness of the floor which is laid on that particular slab, which is approximately 50 mm I am considering. So if I multiply this value with 20, then it will becomes under 1 kilonewton per meter square is the value for that particular slab. Click on apply. After this we will apply the load which is related to the live loading condition for the duplex house. Just I am selecting the previous section. Just I am taking 2 kilonewton per meter square here. Just I am changing dead loading condition to live loading here. Click on apply so that it will apply the load which is related to the live loading condition for the structure. Again we will click on OK option. Now we will apply the support condition system. Before that we will apply the load combination. Click on define option, load combination, default design combination according to the frame as well as the slab. Now after this we will apply the supports. Go to select option, select storage related to the footing. Go to assign, joint, restraints, fixed supports, click on apply so that it will apply the fixed support conditions at the base for this building. Now we will do the analysis process. Before that we will check for the errors for this model. Go to analyze option, click on check models initially. We will check for the joint checks, click on OK so that it will check for the joint check. If any errors are there it will display, otherwise it will display as no warning message here like this. Go to analyze again. Click on set load cases to run. Directly click on the run now option so that it will ask you to save the model. Just I am saving my model duplex. Click on save option so that it will do the analysis process with the considerations of the load cases like gravitational load of dead load, live load for the building model. So now we can see it was done with the complete analysis process. It is showing the deflection diagram for this building model. So the deflection diagram is showing for the dead loading condition system only. In order to change the deflection diagram from dead loading condition to another loading condition system, we have to select the display option. So we have to select the display option here on the top. It will be available here. Click on this option. Deform shape. You can select the load according to the consideration. You can change and we will see the shear force diagram. Frame spandrella. Click on shear to click on apply so that it will display the shear force diagram for this building model. In the same process I am selecting bending moment to 3. Click on apply so that it will display the bending moment diagram for this model. Click on torsion option, click on apply option so that it will display the torsion diagram for this building model here like this. So after this if you want to see the reactions, go to display option, forces, select supports, select all the loads which is of results of the components Fx, Fy, Fz, Mx, My, Mz. Click on apply so that it will display the complete support reactions which is applied at the base by using ETABS software. To design the duplex house building by using ETABS detailing version software. Firstly, we will add the strip condition system before the designing section. For that, we have to unlock the model. Click on unlock option. Go to edit option which is available on the top. Click on edit option. Select add edit grid strips. Click on add. Select the story 2 which is in X direction condition which is added here. Again in the same process, we will add the strip condition system which is related to the direction of Y direction condition system. With the strip layer is B. Click on apply option. In the same process we will select the story number which is of first story for the building model. So here I am selecting story number 1 which is of direction of X with layer is A. Click on apply. In the same process we will apply for the Y direction condition system with the strip layer is B. Click on select your direction which is of Y with the layer is B. Click on apply option. After this we will apply the story number which is related to the ground story level for this building model. Just I am selecting here as ground story which is of X direction A. Click on apply so that it will apply the X direction A grid for this model. Now I will apply for the grid direction which is of Y direction with the B section here. Click on apply option so that it will apply the strip condition system for the y direction. Click on OK option. After this, once again we will do the analysis process for the building model with the considerations of the grids. For that, go to click on the run analysis option so that it will do the analysis process for this building. Now after this, we will go to design option. Click on the design option which is available on the top. Click on the concrete frame design. Click on view revised preferences. Select IS 456-2000. Click on OK. After this, directly go to design, concrete frame design. Click on start designing check option so that it will start designing of the members like beams and columns for this particular building structural model by using ETABS software. All the members are passing here. Now we will design the slab. Go to select concrete slab. Select revised preferences according to IS 456-2000. Click on OK. Again go to design, concrete slab. Select start designing check option so that it will ask you to select the models which is related to the slabs. This I'm selecting here. Click on OK option so that it will select the design the slab section for this particular model. So after this, it will show you the complete strip layer diagram. So now we can see this is the strip layer diagram for the pressure. Now we will save this model. Control S option so that the model will be saved here. Now we will open this particular model in CSI detailing version software. So initially I am closing this ETABS software. Now I am opening CSI detailing 18 software. Click on the file option. Click on the new detailing option. Select open EDB file. So firstly we will select this particular CSI detailing according to duplex house. Just I am selecting here. Initially the model will be open in ETABS software. Then after that it will be imported to CSI detailing version. So here you can see the data is exporting to the CSI detailing. It is showing piers summary not available, spandrella not available. Click on OK. Why? Because we are not considered those sections. That's why it is showing the warning message here like this. Now after this, just I am selecting this detailing units option. Select as per SI system. And select the length will be in millimeter, section thickness millimeter, rebar spacing millimeter, load we have to select as kilonewton. And select the rebar length meter and slab square meter, volume cubic meter, rebar kilogram. Click on OK option. Select the preferences, select as per IS 456-2000, click on OK. Select the rebar rules option here. So we have to select the rebar rules for the slab. So just I am assuming minimum spacing between the bar is 120. I am assuming maximum as 300. Select the beam here. Just I am taking it as 120. This is 120. Again this is also 120 option. Again I am selecting maximum spacing for this model. This is 300. This is 300. This is 300. Click on the column option. Just I am selecting here as 120 and this value is 300 here. Click on OK option. Again we will click on the OK option so that it will do the detailing for this building model according to your considered load cases and specifications for the duplex house. So this is the floor framing plan. This is the rebar plan, top rebar plan, bottom rebar plan, R rebar plan. This is the bottom. This is section A, section B, reinforcement profile for this particular member. Bill of material quantities. Directly click on the rebar KGA option so that it will load the complete rebar KGA for the building structural model which is required for this project. In the same process, you can select the rebar for this particular model. So just I am selecting beam. Just I am selecting elevation, first story beam which is related to this particular model. It is consisting of the reinforcement profile here like this. Directly click on the rebar KGA option so that it will display the complete rebar KGA for this particular model. So you can see extra bar is provided at this particular location for this beam. In the same process, just I am selecting column G ground floor level. Just I am selecting. You can select any one of the column from this particular location. So just I am selecting 3A. This is the A column. This is the B, C. Directly click on the rebar KG option so that it will display the complete rebar KGU for this particular model by using ETABS software, CSI detailing version software. So this is the complete process of designing of duplex house building structural model by using ETABS software. So thank you for watching this video. See you in the next one.